Hello to my online learners. Today we are going to look at tissues. Now this chapter could be overwhelming if you go into all the detail, but we're going to pretty much stay surface level right now, and then when we get to the different types of tissues in the system, we'll go into more detail there. So really the only one we're going to focus on right now is epithelial cell, and then just surface level for the rest. So what we're going to look at is just mainly the classification. So you need to know the 4 classifications and the general function of each. And then we're going to look in a little more detail into the epithelial tissue. Again, you're focusing on characteristics, function, and location. And then look at the different types of connective tissue. Now this can be confusing because this says 7 and then it's all categorized differently in this textbook, which can be confusing. So don't worry so much about the category as more the type and again the location. Then briefly about nervous tissue. We're going to name the parts, not state the parts. Name the parts of the axon. Very surface level here because we have a whole unit on the nervous tissue. And then again muscle, we have a whole unit on muscle. So we'll spend more time on the last type of tissues when we look at those tissues in the areas, when we look at muscles and nerves. Okay, I'm also going to work today off a PowerPoint. And the PowerPoint is found on Blackboard underneath PowerPoint. So if you go here to Blackboard, if you look on the side here, oh, that one's my version, not your version. If you look on the side here, you will see there are PowerPoints. Now, these are the PowerPoints as given by the publisher. I will not make them specific to this topic, but I use it as a reference and refer to them because some of you like to see the nice printing. So this is what we're working with in terms of the PowerPoint for Chapter 5. And again, this PowerPoint is good in some areas, but not in others. So when we look at types of tissue, first off, the definition of a tissue is a group of cells working together to perform a specific general and common function. And there are 4 main classifications: epithelial, connective, nervous, and muscular. So epithelial basically line and cover, connective connect, and connective is kind of the leftover category, but connective tissue will have cells in a matrix. Nervous tissue are excitable and transport signals, and then muscle tissue can contract in various reasons. Now, there's this diagram that shows where it all comes from. It's really interesting to see where the tissue comes from, but again, this isn't testable in this course. Let's look at epithelial tissue. The main function of epithelial tissue is to cover, line, form glands, and this is the important tissue that separates the human body from the environment. So it's exposed to the human environment. That's why it's dead. Everything you see here, dead, except for, well, most of me is dead. So all these people who put all this energy into your skin, don't do it on the outside. This is dead. Do it on the inside with good nutrition. And I noticed during Christmas I had a lot of crap because my face had those little volcano zits. Okay, so epithelial tissue also is important at adhering connective tissue at the bottom, and it has this thing called a basement membrane. Now, the interesting thing about epithelial tissue, it's easily classified by shape and by layers. So if the shapes are, let's look at the textbook here because the textbook has a beautiful diagram that shows all the shapes. There we go. So in the textbook, I love this because this one makes sense. This is squashed, so it's squamish. Then you have cuboidal, which is cube, and columnar, which is a column shape. And these pretty straightforward. There's kind of an in-between shape in some of them, but they're pretty straightforward in their shape. So if you think about squashed or squamish, they are good at covering the surface area. So they're large, they're flat, you can lose a couple, no big deal. Columnar or cuboidal are good at transporting things, and these aren't that common. They're found in the kidneys and the oviduct. And then look at the columnar are very good at also transporting things, and these are the ones found in the lining of the gut mainly. So one classification of epithelial tissue is through the shape. Then in the textbook it shows lovely jobs of the layers. So your layers can be either simple or it can be stratified. And there's another one called pseudo-stratified, which is kind of a combination of both. But we're basically just going to look at simple and stratified. If you're stratified, you have layers. And then you get the different tissue types by putting the two different words together, the two different classifications together. There's also glandular epithelium, which is found in a gland. And we'll be talking more about glands and ducts when we need them in mainly the digestive system. We'll talk more about glands. But if you realize glandular epithelium is good at secreting, has specialized cells. And again, we'll look at the specialized tissue in the system as opposed to just learning a bunch of stuff here. Now, what I do want you to know is beautifully summarized in the table that has no table name on it, and that is this this table on page 77 of the textbook. So this is about the information, the level of the information you need to know about epithelial tissue. So when you have simple squamish, this is a layer. It is, the location is where you want things easily to transfer through. So these are the alveoli. These are the lining of the blood vessels. So you want very simple, easy transport, because when you're diffusing things through, distance matters. Good. The next shape we're going to look at is cuboidal. Now, cuboidal is where you're secreting and absorbing. So this is really the oviduct and the kidneys are the main areas you'll find them. They're cuboidal because they look like little cubes. And then you have columnar. Now, columnar are columns. And those are in areas where you actually want the cell to participate in absorption. So here you have mainly the guts. There's also different types of cells called goblet cells, and the goblet cells secrete mucus. So this way you your cells are not attacked by the acidity, and also it helps lubricate. Now, there is something called pseudo columnar, and this is where it looks like you have more than one column of cells, but if you look at the nuclei, really you just have long, tall, squishy cells, and they look like they're in layers, but they're really only one. And the perfect example of this is in the respiratory tract. Now, when you look at stratification, you can have stratified squamish, and this is skin. So the best thing about your skin, it's in all these layers. The outside is dead, so this way you can flake off a little and it doesn't matter. And as the cells become get pushed to the outside, they're filled with keratin, and keratin is very waxy, so this way it's very good protection against any sort of pathogens from coming in, and also it's pretty resistant to abrasion. So your skin, healthy skin is important for a healthy body. Then there's this interesting one called transitional, which means as it stretches, the cells will change shape from cuboidal, and then they'll flatten to squamish. These are in places where you want organs to stretch. So the perfect example of that, there's two of them. One is the urinary tract. So as you fill your bladder, it will stretch, and actually as it stretches, it becomes watertight. And the other is in the uterus. So pretty much two good organs that need to stretch. So that is the level that you need to know for the epithelial tissue. You need to know the shapes, you need to know the stratifications, or whether it's simple, and you pretty much need to know the functions and the locations. That's pretty much it. Okay? Next is the connective tissue. Now, with connective tissue, the things about connective tissue is it's the wide variety category, sort of the if all else fails, you're at connective tissue, and most of them connect. Now, when you look at connective tissue, they usually have cells in what's called a matrix, and there's different classifications of the matrix, but at this level, I want you to mainly pay attention to what they are. Now, the easiest thing to look at is the type of fiber. So let's start with dense connective tissue. Dense connective tissue has very dense fibers, and as a result, it is very strong and it's got flexibility but no stretch. So this is your ligaments, and ligaments hold bone to bone. So you want some flexibility there and movement, but you do not want it stretched because you don't want your bones moving around. Okay? It is dense because you have all these collagen fibers densely packed together. And if we compare dense with loose, down here is a type of connective tissue called alveolar. And alveolar is loose. And if you look, there are two types of fibers that are very obvious. You've got your collagen tissues, which add some strength, but it's in a network or a net, so it stretches. And then you also have these thinner elastin fibers, which add elasticity. So because there's this elasticity, you have stretch, but you also have collagen for strength. So this is the type of tissue you want: strong but stretchy. So a perfect example of this is found in the lungs, because you want them strong, but you want them stretchy. Okay. Another type of fibrous tissue is reticular, and it's kind of got reticular. Rect means straight. If it's a rectangle, that's something straight. So reticular has a framework of a lot of straight things. Now, you can tell these are connective tissue because you have your matrix or your stuff with your cells inside of it. Okay, so those are your, here they classify it as alveolar, but alveolar to me is just a type of loose connective tissue. Okay, another type of connective tissue that's got a loose open pattern is adipose tissue. And adipose tissue looks very bubbly or very open net with nothing else in between it. And that's because the fat is stored in these globulars here, and then you've got your wee little nuclei, and then you've got your blood vessels to go through it. So in adipose, you have a very good blood supply, but in the staining process, these fat cells, the fat disappears, so you end up with an empty open net. So this net-like structure is for storage of fat. Now, fat is an excellent insulator, and it's also good for cushioning. So this little cushiony bit on your palm is for fat. So adipose tissue is good for energy storage, cushioning, and insulation. And it's an open net, but not a lot of give to it. So if you see this, the alveolar, it's more loose, so it's got a give. This is an open net pattern, but not a lot of movement, but it's got a lot of squish in it. Okay. Now, bone is another, let's continue on with follow through here. So we've got alveolar, you've got your two fibers, your collagens and your elastin. Now, alveolar are usually connective to something else. And this is what surrounds the blood vessels, the nerves. It's a surrounding, it's loose, it's strong, but flexible. Then you have your adipose tissue, which is your fat cells. It's protective, it's storage, and it's insulated. Then you've got your reticular tissue. It's a loose framework, so this acts as a filter, but yet it's strong. So this is found in your spleen, your lymph nodes, and your bone marrow. So those are your connective tissues. Now, the next one to look at is cartilage, and there's 3 different types of cartilage based on how many fibers are in it. So let's go back up here to your cartilage. Cartilage to me looks like fried eggs or eyeballs in line. So you've got your some collagen in it, but then you also have your cells in it. Now notice, no blood vessels. And this is one of the reasons why cartilage is so difficult to heal. There's no blood vessels. Anything that needs to get into the tissue has to diffuse in through this matrix. Okay? So cartilage changes based on the amount of fibers in it. And when you look at the fibrousness of it, you've got hyaline, which is kind of glassy. So it doesn't have that much fiber in it. Then you have, in your earlobes, you have another type of fiber, which is more elasticy, and it's very flexible. So on your bones, on your hyaline cartilage is more for cushioning. Elastin is more for bendability, and this is in your ears and in your esophagus, so it's strong but flexible. And then the strongest one of all that has more fibers in it is fibrocartilage, because it's very fibrous, and it's found where there's a lot of compression, such as in your discs, in between your intervertebral discs, because you want to have the ability to have the compactness there. Good. So that is cartilage. So then another one that looks like cartilage but is different is bone. Let's look at bone. To me, bone is so beautiful. And we'll talk more about bone when we talk about bones, because we have a whole, you getting dizzy yet? A whole chapter on bones. When you look at bones, there are rings and rings and rings, sort of like around a tree, but your bones are not just one big tree trunk ring. It's a bunch of little tree trunks all put together. So you've got these big hollow spots in the center that allow for blood vessels to come through. And you can also have some blood vessels come up in between the rings. So as a result, bone has a very, very good blood supply. So it's strong with calcium and phosphate for strength and support and leverage for your muscles, but it has a very good blood supply, which makes it a perfect storage for your minerals, such as your calcium and your phosphate. And your bones keep remodeling as you grow, not so much once you get to about your 50s, 60s. I think it's, but before then, especially when you're younger, your bones will remodel and the minerals come and go. So this is why bones heal very quickly. Okay, the last type of connective tissue we're going to look at is blood. And we'll go into more detail on blood in the blood unit. But I want you to realize that blood is cells floating in a fluid. So the matrix for this one is very fluidy, not a gel. And you have three types of blood cells. You've got red blood cells, white blood cells, and platelets. But right now, I just want you to know that blood is a connective tissue with cells in a fluid. And that's pretty much all we want for blood at this level. We go into a lot of detail on blood in the next unit. Okay, so that is the type of connective tissue. I want you to be aware of, again, what the type of connective tissue is, what its function is, and mainly where it's found. And here is a lovely table right here. Again, a table without a table reference. But here's a really good example. Don't worry so much about the classification of the loose fibrous, but there are 1, 2, 3, 4. Yeah, these are the examples here, the location and the function. Beautiful table, would make a great matching question. Good. Okay, now when it comes to the nervous tissue we'll talk about in more detail in the nervous unit. But basically, the nervous tissue is a neuron, which is excitable, and it is the tissue that conducts the electrical signal. And then you have neuroglia, and neuroglia are the tissues that support and assist the neurons. And we'll talk about the different types of neuroglia when we talk about the neurons. But you may have heard of myelin and Schwann cells. That's an example of neuroglia. If the neuroglia goes down, your neurons will die because you don't have the support and protection of it. When you look at the nerve itself, you have a cell body or a soma. then the information coming in is in the dendrites, and as the information leaves, it's an axon. Very simple nervous questions right now because we'll go into more detail in the nervous unit. Okay, last type is muscles. And again, we'll go into more detail in the muscle unit, but there are 3 types of muscle tissue. And these 3 types of muscle tissue are skeletal, which is mainly in the skeleton, cardiac, which is in the heart, and smooth muscle, which is pretty much in the guts. When you're looking at muscles, you are looking at basically is there striations or not striations? Where's the location of the nuclei? Is it branched or not? And is it stimulated by itself, which would be it's involuntary, or do you need the nervous system to stimulate it, which is voluntary? So let's look at skeletal muscle. And skeletal muscle has these striations in it, and the nuclei are on the outside. They're very cylindrical looking, and they kind of look like stacks of wood. Good. With cardiac, and in order to get your muscles to contract, a nerve must actually contact each muscle fiber in order to get it to contract. They don't conduct among themselves. Unlike cardiac muscle, where there's these things called intercalated discs. An intercalated disc is how one cardiac muscle communicates with another cardiac muscle. So once it's signaled, they'll all contract in their own way. When you look at cardiac muscle, you have striations, but you have these branching bundles. And also, this is now involuntary. You don't have to think about your heart, just like you don't have to think about your guts. So these are involuntary. So, in terms of striation, we need to talk about smooth. Smooth muscle, no striations. They're long spindle shapes, and the nuclei are in the center. So in terms of categorizing, striations are skeletal and cardiac. Involuntary are cardiac and smooth, and then branched is cardiac. And at this level, that's pretty much all you need to know in this chapter. When we get to the muscle chapter, we'll talk in great more detail. Okay? So that's all you need to know for muscles, which is the 4 groups. Now, when tissue repairs itself, depending on the cut and the depth of it, it can be either regenerated or it can be fibrous. Let's go to the PowerPoint for this one because it's summarizing it, and that is very small. Okay. So when you look at tissue repair, ideally, what happens with tissue repair, and I just want you to be aware of these stages. I won't grill you on each one of them, but initially what you have is a damage, and again, the amount of repair depends on the amount of damage. And then you have a blood clot first to prevent it. Then you have fibroblasts, which come in, lay down cartilage, and then the cells will become fibrous and replace. Now, depending on the damage, you can have 2 types of repair. You can have regenerative, and regenerative means you have less damage and your cells will be replaced with the exact same type of cell, and it is also functional. So there's no scarring. Bone is a very good example of this, usually, unless it's a big break. What happens, or even if you just do a little cut, no scarring, because the cells replaced with same cells, no scarring, completely functional. If you have severe damage, you'll end up with what's called a fibrous cell, or a fibrous repair. And in fibrous repair, you have more collagen laid down in order to hold the tissues together. And that collagen will then impede the function of it, so it's not normal, and you end up with scarring. So scarring prevents normal function. So when you're talking about tissue repair, there's 2 types of tissue repair, and it's here in the PowerPoint, or it's in the textbook, but it's very squishy right here. So here in small print, regeneration occurs when the damaged cells are replaced by the same type, normal functioning. Then fibrous is when damaged cells are replaced by scar tissue, which is because of collagen, and the scar will hold the wound together, but it does not restore the function, okay? And this will cause it to partially impair function if there's too much of it. Good. So that is the function of it. Just a second. Here is our reading topics. Good. And now we need to look at, oh, the regeneration is in chapter 6 here. No, I have to put it back in. Okay. You need to know the difference between regeneration and fibrous. I thought it was there. Okay. Next, let's look at serous membranes, and then we're done this chapter. Serous membranes are basically membranes that will separate things. So there's all sorts of membranes, and a membrane is usually a thin layer of tissue around a cavity. We'll talk about mucous membranes more when we talk about the areas where they have mucous membranes, such as the respiratory tract and the digestive tract. When we look, then we will look at membrane type number 2. Cutaneous membranes is basically the skin. We'll look at that a little bit more when we talk about the skin. And then the serous membranes is something we don't talk about later, so let's look at it now. Serous membranes are simple, squamish, resting on thin layers of connective tissue, and they line some closed cavities and they cover some other cavities. Okay? And they're named based on what they are covering, and there's usually 2 or 3 layers. So you have your pleura have to do with the cardia, or the lungs. So you've got your parietal is on the outside, your visceral is on the inside. Anything visceral means gut. So the visceral pleura is toward the gut. The parietal is outside. Then the other one is the pericardium. Pericardium is the membrane that surrounds the heart to protect it, and yet to allow for lubrication between the membranes to allow for movement. Now with the pleura, you have them stuck together, but you still have movement and sliding. And the last one is the peritoneal. And the peritoneal is the lining around the abdomen to basically keep all the guts together. Now the important thing about these is they have lubrication in terms of water, because water is a good lubricant, to help them slide past each other and yet stick everything together. Okay, and that is pretty much the detail you need to know for chapter 5. So don't get stuck or bogged down in the detail in this unit, because there's a lot of detail. Pay attention to this, and this layer will, or this will keep you with the detail. Good, thanks.